quick review of these properties and laws of logarithms then. Okay. Okay, some of the basic properties: log of 1 equals 0, which makes sense because anything raised to the power of 0 is 1. Same thing, natural log of 1 is 0. We talked about these the other day. Log of 10 to the k equals k, or natural log of e to the power of k is k. All right? Because the log of 10 and the natural log of e, those are inverses of each other. So since they're inverses of each other, they undo each other, which would be why these two are both equal to k. And similarly, right, if I have 10 raised to the power of log of v, or e raised to the power of natural log of v, right, then those two equal v, right, because they undo each other. Right? Those are things you did the other day when you were simplifying those expressions, okay, which we didn't simplify multiple choice question number 3 very well on that quiz. Okay? All right, which was the natural log of e to the 1/6, or to the, what was it, the 6th root of e, natural log of e to the 6th root. And so you should have written that as natural log of e to the 1/6 power, which would have simplified to 1/6. And many of you did not do that correctly. Okay. All right. All right, so if we use the properties of logarithms to solve this equation, just like we did number 4 there, all right, that since this is the log of x minus 3 equals 1, then we can write this as, because the base here is 10, so we would say 10 to the first power is equal to x minus 3. And then add 3 to get 13. Because the base here is 10, so 10 to that power equals that. And that's just changing it from logarithmic form to exponential form and using that to solve the equation, which we did those things the other day. We just said, okay, so it's a log of x minus 3, what does it equal? Right? All right, now the specific laws of logarithms. The first law or property is the product property, product law. It says if I have the log or natural log of a product, I can pull that apart and say it's the log or natural log of the first factor plus the log, natural log of the second factor. All right? So the log of v times w is the log of v plus the log of w. Natural log of v times w, natural log of v plus natural log of w. So on your packet for number 2 here, it says use the log of 3 and log of 4 to find the log of 12, because the log of 12 is the log of 4 times 3, so I could say that's the log of 4 plus the log of 3. Or to use 3 and 6 to get 18, the natural log of 18 is the natural log of 3 times 6, which I could write that as the natural log of 3 plus the natural log of 6. This is the product law or product property. So if we're multiplying, when we have the same base here, we can add those things together. Because Remember when we were working with exponents, if we multiply with the same exponent, if we had the same base and we multiplied, what did we do with the exponents? Add them. Okay? That's where this rule comes from. Multiply same base, add the exponents. Multiply the log of a product is equal to the log of the factors, the sum of the factors. Kind of. Mm-hmm. The quotient property says that if we're dividing v and w, then we subtract. Log of v over w is equal to the log of v minus the log of w. Natural log of v over w, natural log of v minus the natural log of w. It's the quotient law. All right, same thing. If I'm dividing with the same base, I subtract the exponents. So if we're dividing here to find an answer, then we're going to subtract those things. So to get 5, we would do the log of 40 divided by the log of 8. To get 4, do the log of 32 divided by the log of, or divided by 8. All right, so log of 32, natural log of 32 minus natural log of 8. So product law for multiplying, we add them. Quotient law for dividing, then we subtract. Well, it works the other way around too. If I'm subtracting, that means division. If I'm adding, that means multiplication. Okay? Because lots of times we end up using these properties more backwards than forwards. Okay? Little caution over here to understand those are not the same. The natural log of 7/9 is not the natural log of 7 divided by the natural log of 9, because it's the natural log of 7 minus the natural log of 9. The power law says that if I have the log of something raised to a power, I can take that exponent and I can move it to the front. So we take this exponent here, k, and we can move it to the front to get k log of v. So if we have the log, so if we have a power or a number in front of the logarithm, the coefficient of a logarithm, then that number just goes to the power of whatever that is. So here for letter A, that's the log of 25 to the 1/4 power, right? Okay, so I can take that 1/4, move it to the front, and I have 1/4 times the log of 25. Natural log square root of 22. It's 22 to the what power then? 1/2. All right, so then we can move the 1/2 to the front and do 1/2 times the natural log of 22. Those are the main 3 laws that we use, especially now that we have calculators that are more advanced. All right, back in that we will look at in lesson 5.5a, we'll look at other bases besides 10 and e. And because you have the updated calculators, those are really easy to do on your calculator too. Right. So whenever you're simplifying logarithms, right, if you have a coefficient of a logarithm, that has to go to the exponent before you can do any simplifying. Okay? So in this question number 5 here then, we need to, the first step in doing this is rewriting it so this 3 in front of the logarithm becomes the exponent. So x cubed minus 2 log 2x squared. Oops. Why did I write a 2 there? All right, so since this is a plus, we're going to multiply the 8x and the x cubed. Since this is a minus, then the 2x squared is going to go in the denominator because it means divide. So we have the log of 8x times x cubed over 2x squared. This adding means we multiply them, subtracting means we're going to divide. So when I simplify this, get the log of 4x squared, right? 8 divided by 2 is 4, x to the fourth, right? Divided by x squared. But just have to remember that if you have a coefficient of the logarithm, it's got to go to the exponent first. Now, let me ask you this. Could I take this 2 here and move it to the front? Okay. And the answer is no, because the 2 is only the exponent for the x. It's not the exponent for the 2 here also. Okay. For me to be able to move that to the front, I would have to have that whole thing raised to the second power. All right? Since it's only the x raised to the second power, I could not move that 2 legally. Okay? Against the law. All right? You can be arrested for things like that. I don't know. I heard on or saw something today that some elementary kids down in Georgia or something like that were arrested for watching a fight happen and not trying to stop it. That's what I saw.
That's stupid.
Yep. Number 6.
Then everyone needs to be arrested who's ever watched a fight and not stopped it then.